We learned the product rule in the preceding lesson. Then how about a quotient function? So if a function is a rational function or is a quotient of two functions, what will be its derivative? So let's look at the quotient expressions, like 2x minus 1 over x squared plus 1, square root of x over 1 minus 3x, x cubed over x minus x squared, brackets to the power 4. When we have such a function, how can we find its derivative? So today we need to introduce the quotient rule. Let's derive the quotient rule. If q of x is a quotient of two functions, u of x divided by v of x, how can we find a q prime x? Since we have already learned the product rule, we change the quotient form to the product form. We multiply both sides by v of x. We can change this quotient to the product form. Therefore, u of x equals q of x times v of x. Then we apply the product rule to differentiate u of x. So u prime of x equals q prime times v plus q times v prime. And you need to remember, my goal is to look for q prime x. Therefore, we keep this product on the right side. Then we move this one to the left side. Then swap both sides of the equality. Therefore, we can get the blue one, which is q prime x times v equals u prime minus q times v prime. What is q? Q is u over v. So I sub u of x over v of x for q of x. So we replace q of x with this quotient form. Then we find the common denominator in this difference. Therefore, I can get the pink one. So q prime x times v equals u prime v minus uv prime divided by v. I need to look for q prime. I divide both sides by v of x. That's why I can get q prime x equals u prime v minus uv prime divided by v squared. This is the quotient rule. Let's look at it. What is the quotient rule? If q of x equals u over v, then q prime equals u prime v minus uv prime divided by v squared. So if you don't want to represent every single notation as a function notation, we just can write down the quotient rule simply. So like y equals u over v, then y prime, which is the same as dy over dx, equals u prime v minus v prime u over v squared. We have a riddle to help you remember this quotient rule. So it's called low d high. Low times the differentiation of high minus high d low. High times the differentiation of the low. Then draw the line and down below, denominator squared will go. So usually later I will just say low d high minus high d low divided by v squared to go. Right now let's apply the quotient rule to find each derivative. Let's review the quotient rule again. So y prime equals low times differentiation of high, low d high minus high d low divided by v squared to go. The v is always the low. Low means the denominator, high means the numerator. So this is u, this is v. So u is x squared minus 3. V is 3x minus x squared. Find u prime. It's 2x. Find v prime. It's 3 minus 2x. Then the y prime, which is dy over dx, equals low times the differentiation of high, low d high. So 3x minus x squared times 2x minus high d low. So x squared minus 3 times 3 minus 2x divided by v squared to go. In the quotient rule, we expect you to simplify the numerator. You don't need to expand the denominator, but you're expected to simplify the numerator. Let's simplify the numerator. So keep the denominator, the numerator. Distribute 2x into the brackets. So it should be 6x squared minus 2x cubed. Then expand this one. So x squared times 3 minus 3x squared. Negative 2x cubed was this negative plus 2x cubed. Negative 9 was this negative in front plus 9. Plus 6x was this negative sign minus 6x. Combine the like terms. So it should be these two cancel out. 6x squared minus 3x squared, 3x squared minus 6x plus 9. So this is the simplified result for the derivative function of this function. Let's find the derivative of this function. So u is x, v is square root of 1 minus 3x, and change this one to the power form right away. So right now let's find the u prime and the v prime respectively. U prime is 1, v prime is 1/2, bracket 1 minus 3x to the power of negative 1/2, then times negative 3. So you need to apply the chain rule again when you look for v prime. So the outside times the inside. Y prime equals low d high. So square root of 1 minus 3x times 1 minus high d low. So x times, this one should be negative 3 over 2. I put this one back to the denominator because this is a negative exponent. So it should be 2 times the square root of 1 minus 3x. Divided by v squared to go. Square this one. It should be 1 minus 3x. Let's simplify the numerator. So if you want to simplify the numerator, this is a complex fraction because you have the denominator in the numerator. So I just multiply the LCD. So this one is 2 root 1 minus 3x. We multiply the top and the bottom by this 2 times square root of 1 minus 3x. Therefore, we can get 2 times 1 minus 3x times root 1 minus 3x. That's the denominator. So the numerator is this one times this one should be 2 times 1 minus 3x. And this one times this one, you cancel out the denominator. Then you do have plus 3x only. Negative, negative become positive. Continue to simplify the numerator further. Then expand the brackets. So 2 minus 6x plus 3x. So it can be combined to 2 minus 3x. This is the differentiation result of this one. Some of you guys may wonder if we have to apply the quotient rule to find each derivative. You don't have to. We can change each quotient form to a product form, just like the pink one. And thereby you can apply the product rule. But for this one, you still need to apply the chain rule to find the derivative of v. The same, you can change this quotient form to the product form and apply the product rule and the chain rule to find its derivative. Let's continue to practice the quotient rule. In example 2, find the gradient of the tangent to this function at a particular x value. So we need to find the derivative function. This is a quotient form. So u is x squared, v is the square root of x squared plus 5. Let's change this one to the power form right away. So u prime should be 2x. And the v prime, we need to apply the chain rule again. So 1/2 times x squared plus 5 to the power of negative 1/2, the outside, then the inside, 2x. Simplify this expression. We can change this one to x. 2 and 1/2 can cancel out. So x over square root of x squared plus 5. So the differentiation for y prime should be low d high minus high d low. Divided by v squared to go. The square of v should be x squared plus 5. You can see a complex fraction in this differentiation as well. So we need to simplify the complex fraction. We multiply the top and the bottom by the common denominator, which is square root of x squared plus 5. So y prime equals x squared plus 5 times square root of x squared plus 5. Distribute this one in to the brackets. We should have 2x times x squared plus 5 minus x cubed. Expand the brackets and simplify the numerator further. So 2x cubed plus 10x minus x cubed. Keep the denominator the same. Then I can have x cubed plus 10x divided by x squared plus 5 times square root of x squared plus 5. So the particular gradient at x equals negative 2 should be, we sub a negative 2 in for x in this derivative function. It's negative 8 because it's negative 2 cubed. Negative 8 minus 20 divided by negative 2 bracket squared should be 4 plus 5, 9. 9 times square root of 9. Negative 28. This one can be simplified to 3. 3 times 9, 27. This is the particular gradient of the tangent to the curve at this particular x value. Let's go over the skills on the graphing calculator to see if we can get to the same answer using a technology. So we need to go to Math 8. So the first box, let's put x in. So the second box should be x squared divided by the square root of x squared plus 5 at x equals negative 2. So press enter. So let's look at if negative 28 divided by 27 is the same value. That means my algebraic work is correct. There are the homework questions here to help you practice the quotient rule. This is the end of the lesson.